Right. Today I'll be going over um, no, binomial asset pricing models. So without further ado, let's look at one period binomial pricing model. Um, and again, I'd like to say that this is me trying to go over this stuff myself. So don't expect it to be smooth and don't expect it to be uh, me to be very defined in the concepts. Um, I'm just going it over along with you. Over it along with you. Well, yeah, let's start. So one period binomial pricing model. This is the model. The beginning of the time period is T0. I'll use a highlighter. Yeah. And so since it has only one period, the ending time is called time one. Where did that go? At time zero, the stock price is denoted by S naught, and uh, S naught is always a positive number. Since stock prices are always positive, you can't have negative stock prices. An experiment is performed where you toss a coin. Basically, can get you a head with probability P or tail with probability minus P. If a head is obtained, the price moves to S1H. If the tail is obtained, the price moves to S1T. Um, we'll assume that both of these are positive. Obviously, like they have to be positive because probabilities are never negative. They are between 0 and 1. Um, and they are not necessarily equal. So if they were equal, P would be equal to Q, or P would be equal to 1 minus P, which is 0.5. So they are not equal. In other words, the coin not necessarily is a fair coin, right? And we have a definition of up factor and down factors. So up factor and down factors are denoted by S1H by S naught. So basically there's a ratio that in case you get a um, head with probability P, um, the ratio of the price if you get a head or if your price goes up by the initial price, so S naught, and same is for the round factor. And using this relation, you have you have this theoretical prices for S1H and S1T. We also assume that U is greater than D. Um, if you think about it, it makes sense to do so. Uh, why? Because let me see. So here's my pen. Have a pen here. That's not. Oh, you should have a pen. Okay, no problem. Yeah, I'll do one thing. Yeah, so we have initial price. That's not H on E any given moment. Um, right. Um, yeah. So this is how you denote it. And if you have your, so basically, oh, so yeah, S1 is the higher price, right? So you have U as S1 H, S naught, and T as S1 E by S naught. And since you have this relation, and this is greater than this, so yeah, you will always get 20, right? Hope that was clear. Um, let's move on to the so yeah, we are back here, and we often incorporate in this model a short constant interest rate. So we add an interest rate that is usually um, the amount that we are charged, or basically you can also call it as an amount that you would normally get uh, if you're investing in the country's bond. So or you can call it a risk-free rate. So this is the interest rate that is usually charged, and in practice, for applications of option pricing, one typically uses a 3 month or 6 months LIBOR. LIBOR is London Interbank Offered Rate. I think the standards have changed now. We use SOFR or SOFR more commonly than LIBOR. I think LIBOR has been discontinued, something like that. Yeah. Next, in order to rule out an arbitrage model, we would have the following inequalities. So we have this relation where your interest rate needs to be between your up rate and down rate. Why? Because um, otherwise it would give you an opportunity to arbitrage, right? So, like we discussed earlier, going back to the whiteboard, let's see how this is an opportunity for arbitrage. Um, so we are back with our whiteboard, and um, yeah, let's so we had our model. It's not S1 H and S1 T. I need to buy a stylus. I think so. This is fine. So we have this, and um, so the text says that in order to see this, we need to first define a concept for arbitrage. An arbitrage strategy is a trading strategy that allows an investor. That's that's fine. Um, yeah, so it's a strategy that allows an investor to start with zero initial wealth with a time zero and make a profit with non-zero probability without taking any risk. So yeah. We can exhibit such arbitrage opportunities if D is greater than 1 plus R or U is less than equal to 1 plus R. For instance, let us consider a case um, where U is greater than D greater than 1 plus R. So in this situation, what would happen that in the worst case scenario, our payoff would be S naught T based upon the formula that we just looked at as naught 1 plus R. And since we know that D is greater than really need a stylus. Since we know that D is greater than minus 1 plus R, 1 plus R, um, this will always be greater than equal to 0 or greater than 0 if D is always greater than 1 plus R, right? So in this way, you can like exploit an arbitrage at the same. Uh, Similarly, if you have a scenario, and obviously, like if this is possible in the down scenario, in the scenario where your S1H, which is higher than S1T, occurs, the profit will be even higher. So yeah, you are guaranteed profit in that scenario. Um, Coming to the second scenario where uh, your R is greater than both U and D. So in this scenario, what happens? Uh, uh, not D. In this scenario, what happens? So we see that we'll have 1 plus R S naught minus S naught D. And since we have an interest rate greater than D, what we can do is we can short this and basically get a payoff of 1 plus R. Payoff in interest rate, which is greater than D. So we'll always have a profit in this scenario. So this is how you can think um, about single period or one period um, binomial pricing model. In the upcoming videos, we'll discuss a more complex version of a binomial pricing model for options. We'll discuss European call options, and we'll also discuss some concepts related to geometry Brownian motion, stochastic calculus, and a lot more. So that's it for this video. I'll see you in the next one.